Okay, for those who missed class yesterday, go in to student.desmos.com and do the do now by putting in this code 75A FPF. Next, some announcements. The maximizing volume struggle problem part 1 was due yesterday. Maximizing volume part 2, which we're going to take a look at today, is due Thursday. I have office hours Wednesday and Friday. Here's the extra credit problem on why a circle has more area than a square given the same perimeter x. Okay. Review maximizing volume of cylinder. We'll go. Okay, so what we learned, what I want you to get out now is the maximizing volume struggle problem part 2, which you will receive in Tuesday's classwork. Now, a review of what we learned from maximizing volume part 1. A cylinder has a greater volume, holds more water, than a rectangular prism given equal heights and surface areas. Basically, if you're given a certain amount of sheet metal to build the tower, the cylinder works better than the prism because you can hold more water. Then we also found that the volume of the cylinder with a fixed surface area changes with different radiuses and heights. In our situation, the water tower with a radius of 50 feet and a height of 105 feet provided the most volume. We're now going to compare whether a sphere or a cube has more volume than the cylinder given the same fixed surface area. So, I'm going to start you on this problem, but this is a struggle problem, so I want you to struggle through it. So, this 48,000 square feet, which is what we found our money could afford, stands for what? In this A is area, I'm going to put SA to stand for surface area. This 448,000 square feet stands for surface area. So we're given a surface area of 48,320 feet squared, right? And this is the surface area equation for a sphere, which is just a ball, right? A sphere is just a ball. So how much water could a ball hold if it was 48,320 feet of material around the outside? If you had a big soccer ball that had this much material, how much water could you put inside? But instead of soccer ball material, it's metal, right? So if we're given that, there's only one unknown. R is the only unknown in this equation. So you can just plug this in here. 48,320 equals 4 pi r squared. Now, it's just a two-step equation to solve that for r. So you want to get r by itself. All I'm going to say at this point, I'm going to set up an equation similar that looks easier, right? But it's the same problem. 20 equals 2x squared. So this is essentially the same steps to do this. So I'll break you through this. So 2 times x squared is what this says. So if we're solving for x, we do the inverse. So we divide by 2 on both sides, which would get 10. That cancels out x squared. So to solve for x squared, the inverse of square is square root. And so you'd have square root of 10 equals x. You're going to do the same steps over here to find r. At the end of the day, you're going to have the radius equals some number, right? That's what you need to do. So then when you find out this radius, you can plug it in, i.e. substitute for the radius over here to find the volume of that sphere. Okay? You're going to do the same thing with the cube. Remember, a cube is just a rectangular prism with all equal sides, like a dice. If you have dice, it's a rectangular prism of all equal sides. Now, same setup. So I want you to find the volume of that cube. Now, just to check yourself, this is an interesting question. So what you will find when you find the volume of the sphere is that it was more than the volume of the cylinder. Okay? And yet I look out my window and every single water tower I see, every single one, is a cylinder and not a sphere. These aren't big old balls. So why is that? Why do you think the water towers were cylinders and not spheres? I want you to think about building a cylinder versus building a sphere. Think about transporting a cylinder versus transporting a sphere. And then you notice there are cones on top. Why do you think there are cones on top of all these? So that's your follow-up question. So that is a taste to help you out with the struggle problem that is due Thursday. And I have office hours today at noon.